Have you ever pondered how scientists predict adsorption capacity? It's a complex process with some significant limitations. Traditionally, adsorption capacity prediction relied heavily on methods that required extensive laboratory testing. These methods often revolve around using a series of experiments to determine the adsorption isotherms and kinetics. However, these methods have their own set of challenges. One of the key limitations is the lack of accuracy. Despite the rigorous testing, the results can often be inconsistent and not entirely reliable. This is due to the highly variable nature of both the pollutants and the adsorbents involved in the process. Additionally, these traditional methods require substantial time and resources, making them less viable for dealing with a wide array of pollutants. Given these limitations, it's clear we need a more accurate, efficient, and versatile method of predicting adsorption capacity, right? Well, enter machine learning. So, what exactly is this machine learning we're talking about, and how can it help with predicting adsorption capacity? Well, machine learning is essentially a type of artificial intelligence that provides systems the ability to learn and improve on their own. It's a bit like teaching a child how to ride a bike. Once they know how, they keep getting better with practice. Machine learning works in a similar way. It learns from data, identifies patterns, and makes decisions with minimal human intervention. Now, how does this apply to predicting adsorption capacity? Adsorption, if you recall, is the process where certain particles adhere to the surface of an adsorbent. It's a complex process influenced by many factors. Traditional methods of predicting adsorption capacity often fall short as they struggle to handle this complexity. Enter machine learning. With its ability to digest and learn from vast amounts of complex data, it can model and learn the adsorption behavior of pollutants on adsorbents. It's like having a super intelligent assistant who can sift through all the data and identify the patterns that matter. The result? High-quality models that can accurately forecast adsorption efficiency. But the real beauty of machine learning is its ability to improve over time. The more data it has to learn from, the more accurate its predictions become. So, as we gather more data on adsorption processes, our predictions will only get better. With machine learning, we can overcome the limitations of traditional methods and predict adsorption capacity more accurately and efficiently. Now that we know what machine learning is and how it can help, let's delve into the key aspects of the machine learning approach in adsorption. Machine learning offers a novel approach to predicting adsorption capacity. The first step is data collection. This involves gathering a vast amount of data on the adsorption behavior of pollutants on various adsorbents. The more diverse and comprehensive the data, the better the machine learning model can learn and predict. Following data collection, the next step is model training. Here, the machine learning algorithm is introduced to the collected data. It learns the patterns and relationships between different variables. This learning phase is crucial, as it sets the foundation for accurate predictions. Once the model is trained, it's time for prediction. This is where the real magic happens. The machine learning model can now forecast the adsorption capacity of a given pollutant on a specific adsorbent, based on the patterns it learned during training. The benefits of this approach are numerous. Machine learning models can predict adsorption capacity with greater accuracy and efficiency than traditional methods. They're also incredibly versatile, capable of learning from and adapting to new data. This means they can continually improve and refine their predictions over time. So, as you can see, machine learning holds great promise for improving the prediction of adsorption capacity. It's an exciting time for the field, and we can't wait to see what the future holds.